Okay, a radical. When you are looking at a radical, what does a radical undo? A what? An exponent. So a radical undoes an exponent. And then this is kind of like a different way to think about it. But you know how like an exponent is just repeated numbers? So we know the square root of 25. What's the square root of 25? 5. The reason the square root of 25 is 5 is because 25 is 5 times 5. And a square root is looking to undo that second power. So a second power means I have two of the same. So what a square root is doing is it's looking for two of the same to take out. So the reason the square root of 25 is 5 is because a square root is going to look for two of the same to take out. So a square root is looking for groups to take out of 2 because a squared power means I have two of the same. So when you're undoing that two of the same, you're looking for still two of the same. How that translates. Okay, we're going to start throwing variables into this. What's the square root of 36? 6. And again, the reason it is that is because 36 is 6 times 6. Your variables are where it's going to be a little bit different. X to the 10th means how many total x's do we have? 10. So I am going to write out all 10 x's. No, we're only doing it twice. It's fun. So, again, a square root is looking to undo a second power. A second power means we have two of the same. So, a square root is looking to take out groups that are the same. Since it's a square root, it's looking for groups of 2. So the reason that the square root of 36 is 6 is because I can take out that group of 6. When we have x to the 10th, we are still looking for groups of 2. So if I start grouping these things into groups of 2, how many groups of 2 can I make with all of my x's? 5. So the square root of 36x to the 10th is 6x to the 5th. Because again, a square root is looking for groups of 2. And if you have 10 total x's and you're taking out groups of 2, we made 5 groups. Yeah?
What happens if it's uneven? So
then we'll break it up and we'll do ones like that.
Alright.
Okay, the next one. Now what type of radical is it?
Cube.
A cubed root. What's the cubed root of 8?
2.
2. And again, the reason that is because 8 is 2 times 2 times 2. A third root means we're looking for groups of 3. So a third root is going to look to undo a third power, which means we're looking for groups of 3. Same idea with variables. So what's the third root of 216? 6. And that's because 6 times 6 times 6 is 216. X to the 9th means how many total x's are there? 9 of them. So when we take a third root of a number, what we're really doing is we're looking for groups that are the same. Here, I have a group of 6's. Again, third root looking for groups of 3 that are the same. How many groups of 3 can I make out of all my x's? 3. So the third root of 216x to the 9th is 6x to the 3rd, because a third root means we're looking for groups of 3 to take out, because an exponent means I have repeats of those. So a third root is looking to take those repeats out. Pattern-wise, what happened to our variables? So we had an x to the 10th. When we took a square root, it turned to a 5. When we had an x to the 9th, when we took a third root, it turned into x to the 3rd. What operation did we do? What operation means we're looking for groups? I have 100 pieces of candy. I want to put them in 10 groups. How many are in each group? 10. I have 100 pieces of candy. I want to put them in 4 groups. How many are in each group? 25. So what operation are you guys doing? Division. So when we are looking for groups, our variables get divided by the index. And it's because you're looking for groupings that are the same. When you look for groups that are the same, by definition, division is your grouper. Division breaks things up into groups. Number-wise, when we do this, you're just going to use your yellow sheet because our numbers always act like numbers. And once you look into these, you'll be like, oh, it's very consistent. It's kind of nice. It's a nice little break off of what the past 2 days have been when there's so many different ways of doing it. Third root of 64 y to the 6. You guys will hear me say like good and bad. And when I say good, I mean if we look at the third root, this third root means we want groups of 3. So a third root is looking for groups of 3 to take out. Yellow sheet wise, can we take the third root of 64? Yes. Grouping wise, can we evenly take groups of 3 out of 6? Yes. So this is a good setup because what is the third root of 64? Yellow sheet, third root of 64 is 4? Y to the 6th. How many groups of 3, because our index is 3, can come out of 6? 2. Because if we were to like draw all those y's and circle groups of 3, we'd be able to have 2 groups made up of our y's. Okay, next one. What's our index? What's the little number in the nook? 5. So with this fifth root, it means we want groups of 5. Because a fifth root is trying to undo a fifth power. Fifth powers means I'm putting 5 together at a time. Number-wise, you look at your yellow sheet. 32. Can I take the fifth root of 32? Yes. Since we're looking for groups of 5, can I evenly take groups of 5 out of 15?
Yeah.
Can I evenly take groups of 5 out of 30?
Yeah.
So everything here is good. What is the fifth root of 32? When I take out x to the 15th, how many groups of 5 come out?
3.
So do you see how we're just doing 15 divided by 5? For our y's, how many groups of 5 come out of 30? 6. So you just divide. 30 divided by 5 means 6 groups came out. Next one. This is how everything kind of follows in on itself. If we have a radical to a fraction, does that radical happen to top, bottom, or both? Both of them. So when I see x to the 4th and y to the 8th, our index is a 4, which means what sort of groups are we looking to take out? Groups of 4. How many groups of 4 come out of x to the 4th? 1. How many groups of 4 come out of y to the 8th? Number 4, what sort of groups are we looking to take out? Groups of 7. So it doesn't matter what your index is, you're just looking at that. What should we first do to number 4? Simplify. So do you see how on number 4 there's f's on both top and bottom? We can simplify that. Do we have more f's on top or on bottom? Bottom. So they're going to end up on the bottom. And when you're in a fraction, what do you do to your exponents? Subtract them. So what's 33 minus 12? 21. So you are allowed to simplify things first before you do the radical. So a 7th root means we're looking for groups of 7. How many groups of 7 can we take out a d to the 14th? 2 of them. So our new exponent is just a 2. So that just means 2 groups came out of these 14 because we're putting them in 7 at a time. What is the new exponent on the f going to be? 3. Again, you just divide. So your numbers are always going to act like numbers. You use your yellow sheet. Variables, because a radical is trying to undo that exponent, we're just looking to undo those groups that they were putting in together, and we're just dividing them out. The first 4 are really nice, because the first 4, do you see how everything is a nice number? Now when we look at number 5, what type of radical is number 5? A square root. So we're looking for groups of 2. Is 125 a perfect square? No. So we're going to break up that 125 like we've always broken up that 125. What perfect square goes into 125? Times 5. Now, since we're looking for groups of 2, Can I evenly take groups of 2 out of 6? Yes, so I'm going to leave this as is. The y is the problem, because can groups of 2 evenly come out of 5? No, so I want to rewrite that so we have like the good part and what's left over. Just like the 125, we did 25, which is the good part, the 5 is what's left over. So when you look at that y to the 5th, you have to think, what is the biggest number smaller than 5 that you can divide by 2? 4. 4 is the biggest number that's smaller than 5 that you can divide by 2. We still need 5 total y's, so what else how many more y's do we need? 1. So you split your variables just like you split your numbers into the good part and what's left over. Since it's a square root, we need our exponents to be divisible by 2, so you split it. Once you have everything split, then you start taking things out. What's the square root of 25? Can we take the square root of 5? No, so it's stuck. X to the 6th. What will that turn into when it comes out? X to the 3rd. Because again, we're taking out groups of 2. 6 divided by 2 is 3. Y to the 4th, how many groups of 2 come out of 4? What is still stuck on the inside? 5, and then the y1. Alright, next one. What sort of groups are we looking to take out? Groups of 3. So it's a third root. First thing you do is you look at that 135. Is 135 a perfect third power? Nope. So you grab your calculator and you start dividing by what are the numbers that would go into 135? 27 times 5. So we break down the number into the good part, which is on your yellow sheet, and what's left over. Since it is a third root, we want our exponents to be multiples of what number? 3. So a to the 4th, can we evenly divide a 4 with a 3? No, but what is the biggest number smaller than 4 that we could divide by 3?
3.
And then how many are left over? 1. We still need 4 total. B, can 14 evenly be divided by 3? No, but what number could be divided by 3? How many are left over? 2. The line that I have written down right there is the most important line. In this lesson specifically, honestly, the only time kids get kind of goofed up is when they try to take stuff out and figure out what's left behind without first breaking it up. Because if you take the time to break everything up into like the good stuff and what's left over, it goes really quickly. Because what's the third root of 27?
3.
5 is stuck. What's the third root of a to the 3rd? The a is stuck. What's the third root of b to the 12th? And then we have the third root of 5ab squared is left over. I always circle what comes out because it just makes it really quick. If you didn't circle it, it's what's left over. Heads up, what's left over, your exponent should always be smaller than your index. Because if you're taking out groups of 3, if your exponent is bigger than 3, you could have taken another group out. So in the end, we have exponents of 1 and 2, which is perfect because they're smaller than 3. Next one, what sort of groups are we looking to take out? 5. So number-wise, you look at the 4. Do any 5 powers break down a 4? No. A to the 8th. Is 8 evenly divisible by 5? No. But how would we want to break it down? So what number is divisible by 5? 5. And then how many a's are left over? 3. So you still need 8 total. 5 we can divide. There's 3 left over. B to the 14th. 14 is not divisible by 5. But what number is divisible by 5? 10. How many are left over? And then C to the 5. Is 5 evenly divisible by 5? Yes. So just leave it. So take the time to write out that line because that line has the good and what's left over. 4 we can't take out. What's a to the 5th going to turn into? A to the 3rd. Can we take it out? Nope. What about that b to the 10th? What will that be? B to the 4. Can we take it out? Nope. What's c to the 5th going to turn into? And then we still have the 5th root of what's left over. And make sure you guys are putting your little numbers in the nook. Because if you don't have that little 5 in the nook, you've just made it into a square root. And we can't just change radicals from one type to another. Okay, last one. What sort of groups are we looking to take out? Groups of 4. Okay. 125. Look on your 4 list. Is 125 a 4th power? No. So using your list, what number would go into 120 or 1250, not 125? So numbers, you always just go off of your yellow sheet. You break it down like we have been. X to the 4th, is that good or bad? Good. 4 we can divide by 4, so we're going to leave it. Y to the 9th, good or bad? Bad. How do you want to split that 9?
8.
Good. So 8 is the biggest number that could divide. There's 1 left over. Z squared, good or bad? Bad, but can we split it 2 at all? No. We need at least 4 to take it out, so if it's smaller, it's stuck no matter what. When that 625 comes out, what is it going to turn into? What else can come out? And what will that turn into? What else? And then, yep, our y to the 2nd, because we can divide. And then we still have our 4th root of 2y z squared. I think this lesson is a little bit nicer than the last 2, just because it's more like procedural where you do the same thing every time. We are going to start the homework together. So we're going to do the first 4 on the homework together. Yes, if you can wait like a minute, you can do the last one. If not, just come when you come back. Or the last 4. First 4.
Alright.
There might be an extra one. Alright, so the reason I want to do the first 4 is that these are in Friday's notes. Alright, starting with number 1. What is the square root of 225? Why? Because it's 15 times 15, right? So square root, 15 times 15, so we get 15. Number 2, what's the third root of 512? And it's because 8 times 8 times 8 is 512. So a third root is looking for groups of 3. Jumping to number 4. What's the 4th root of 1,296? Why? So then number 3. Number 3 is different. Why is number 3 different? It's a negative. So if we just ignore the negative, what's the third root of 64? 4. So how does the negative change this? We don't have eyes. Yeah, if all of these are negative 4s, what's a negative times a negative times a negative? It's a negative. So, in this unit, we are not dealing with imaginary answers. We're only dealing with real answers. Because negative numbers come in groups, if you have an odd index, like a 3 or a 5, a negative can come out of it just like a negative. So under a third root or a 5th root, if you have a negative number, that negative just comes out, because if you have an odd amount of negatives, your answer is still negative. So I think it's numbers 8, 15, and 16. That negative just comes out. So under a third root, a negative on the inside can just move to a negative on the outside. So the negatives, just move them out on those ones. You'll get more practice with that on the next lesson.